Hello, Royals. Let's do more examples of simplifying rational expressions and stating their restriction. So here's an example. I think it's called number 6 from this lesson. We have 5x squared plus x minus 4 divided by 25x squared minus 40x plus 16. A ratio or a quotient of two polynomial functions. And we want to simplify this expression. Very serious, but also relatively common mistakes are students that just start canceling a 5 and a 25 there. What we're trying to do is we are trying to divide factors. And the argument is that 5 is not a factor in the numerator, 5 is not a factor in the denominator. We want to be able to find factors to divide. You don't cancel stuff. Please don't use the word cancel because then you won't understand the restrictions. Okay? As far as our factoring goes, you could try to squeeze in your little x method up here. But I don't know, with the polynomial 5x squared plus x minus 4, 5 is prime, right? So you know it has to be 5x times x. That has to be the case. There's no, if it does factor, I guess I'm assuming it factors. And I'm pretty sure I don't want a 4 here to get a 20 to get 1. I also don't think I want a 2 here to get a 10 and then manage to get back to a 1. I think I want 5 and 4 to get 1. So let me put 1 there and 4 there. I want 5x minus 4x. Now, some students in grade 10 or coming from grade 10 said they found the factoring so easy in grade 10 that they didn't ever need to develop the method of the X method or lollipop or decomposition or whatever. And that's good news. Just make sure you're willing to learn. But I don't want you to stop using a strategy if you think you can just sort of see how it factors. That's great. Now, you could be a little bit sneaky here as well. And if you assume that there is any kind of factoring that is going to be done here, then you could assume that, or let's say hypothesize that one of these factors is going to show up in the denominator. If I had to guess between these, both x plus 1 and 5x minus 4 could potentially be factors in the denominator. I'm not sure if I have one reason for thinking one may be the case over the other. Maybe the fact that I'm looking for two numbers that multiply to a positive and add to a negative tells me that it can't be x plus 1. But maybe I shouldn't worry so much about tricks. If you use your X method, though, and you use it properly, then the first two numbers that you'll be trying will be 5, 5 and 4, 4. Notice that 20 and 20 will add to negative 4. This is where you don't need to treat a perfect square as a different type of case. But when you're using the X method on a perfect square, you might want to maybe just eyeball these first two options to see if it works, because you could save yourself a bit of time of not having to write out all of the other factors. Let's check. I checked the numerator already. Let's check the denominator. 25x squared minus 20x minus 20x. That's minus 40x plus 14. Looks good. Okay. And now, there's a couple of different ways of thinking about what's happening here. Most students like saying this 5x minus 4 is divided by that 5x minus 4 as long as 5x minus 4 isn't 0, because any number divided by itself is always going to be 1 as long as that number isn't 0. To be a little bit more technical, we are multiplying the numerator by the reciprocal of 5x minus 4 and multiplying the denominator by the reciprocal of 5x minus 4, which has the same restrictions. And then that factor and that factor divide, this factor and this factor divide. But that takes a lot of work to show. Okay, I think that the stronger, you'll see me sort of using this approach because I leave a factor of 1 in both, in the numerator and the denominator, which I think is just good practice. When students have that use the word cancel, remove everything, they're sometimes left with nothing and they write a 0. If you understand that you are dividing these factors, you know that a number divided by itself will reduce to one whole right there, as long as that number isn't 0. So we receive the simpler expression, x plus 1 divided by 5x minus 4. It doesn't really require parentheses in its numerator or denominator anymore. The bracket, the fraction bar does that on its own. It's not a bad idea to have them, though, especially if you're going to be finding a common denominator later. And this will be the case as long as 5x minus 4 is not equal to 0. Most common mistake here is students that were just taught that the root is the opposite of that number, and that's not the case. You should be You don't need to show all of these steps, but you should be able to solve this inequality just like a linear equation. Okay. You also shouldn't be memorizing. It's the opposite of this divided by that. Just use your linear skills. You want to minimize the amount of memorization required here. So you shouldn't forget how to figure out what this restriction is. This restriction would be in place whether that factor remained in the denominator or not. Okay. Let's find another. Example 7 has multiple variables on it. It's not going to happen. I don't think it's in our curriculum, but it's definitely in our homework. And you'll be doing more advanced factoring like this in other classes as well. So I've got an x squared minus 7x plus 10y, or sorry, 7xy plus 10y squared divided by x squared plus xy minus 6y squared. So factoring this expression should be as easy as factoring x squared minus 7x plus 10. Factoring the denominator should be as easy as factoring x squared plus 1x minus 6. Fine. In fact, factoring both of those expressions would be the same as factoring 1 minus y minus 6y squared, which I would suggest you should try doing in that order. See, the letters don't really concern us too much. It's just the coefficients, the numbers that we're interested in. Let's see if we can speed this up with a little bit of inspection. That would have to be x times x. I check for common factors first, of course. When I'm looking for a common factor, I'm almost only ever looking for a common factor for all of the terms. Pretty sure this is going to be a y and a y because of the y squareds and the xy in the middle. Pretty sure these signs are both going to be negative for my product to be positive and my sum to be negative. Then I'm looking for factors of 10 that have a sum or a difference of 7. Let's try 5 and 2. X squared minus 2xy minus 5xy. That'll give me negative 7xy. And then there's the plus 10y squared. Here, let's actually do the x method on this one right here, although I'm a little tight for space. I'll squeeze it up there. Y squared. 1, 1 and 1, 6, 6 and 1 are 3 and 2. Let's see, 1 times 2 is 2, 1 times 3 is 3. With 3 and 2, I can get positive 1. If I do 3 minus 2, positive 3 minus 2. These are the coefficients I'm going to use. I just need to put, actually, I'll put the coefficients in. It's going to be positive 1, and positive 3 with negative 2. But I don't like doing this first because sometimes I forget the variables. 1 times 1 will give me a 1. Well, how do I get the x squared? That's x times x. 3 times negative 2 gives me negative 6. How do I get the y squared? That's y times y. It shouldn't be any harder factoring with like y's and y squareds in there combined with the x's. It does confuse some students sometimes though. Okay, I'm checking with multiplication. 1x squared minus 2xy plus 3xy. 3xy minus 2xy is 1xy. Positive 3y multiplied by negative 2y, negative 6y squared. What? X, I didn't use our little prediction trick here, did I? Not worth it, I don't think. Scanning for shared factors. There's no factor of x squared here. X squared and x squared can't divide out because x squared isn't being multiplied. X minus 2y could be divided out because x minus 2y is being multiplied. The entire expression is being multiplied. I could divide this x minus 2y by this x minus 2y as long as x minus 2y isn't 0. So I'm left with the simpler expression x minus 5y divided by x plus 3y. And my restriction here is that x minus 2y can't equal 0. So the fact that our factors have multiple variables here means that our restrictions are stated a little bit differently. Sometimes restrictions will be stated in terms of other variables. So, oh, and I've got this restriction as well, that x plus 3y also can't equal 0. I think the best that you could do here, since it's probably easiest to do so, is just isolate for x. And in this case, you would say, well, x can't be the double of whatever y is. And here you would say x can't equal whatever the opposite of the triple of y is. It's 2 lines of restrictions. For example, if y is 7, x can't be 14. If y is 0, x can't be 0. If y is -1, x can't be -2. So there's no one value that x can't be. It's the relationship between x and y that has to be considered. Okay. Now, the thing that sometimes causes confusion here is students might be unsure whether they need to state their restrictions in terms of x or in terms of y, because we could do both here. I could divide both sides by 2 or multiply both sides by 1/2 and say, one person might say x can't be the double of y, and someone else might say, I got a different answer. I got that y can't be half of x. Those two people are silly because they're arguing the exact same thing. One person might say x can't be the opposite of 3y. Someone else might say, no, you're absolutely wrong, you fool. It's the fact is that y can't be the opposite of a third of what x is, and they're both right, but probably both wrong for arguing about it as well. Okay. Last thing I wanted to look at, in class, I did the reversal factoring here. I factored it in the order that it was given, which I think you want to try. But just to present an option, I do want you to feel comfortable changing the order of expressions if you're more comfortable with that. Just make sure that you are factoring properly, like using good factoring formatting, and don't leave a leading negative inside a bracket. This entire time, these last two steps, I haven't done anything with the denominator, which I think maybe I could have done. But I don't know, maybe subconsciously I realized that writing out a trinomial is a little bit faster than writing out the product of two binomials, because then I'd have to write like two signs, 4 coefficients, so one more coefficient, and 4 extra brackets. I'm not sure what the case is. X squared minus 1. Difference of squares works nice. Let's see, 2x squared would have to be x and 2. 7 is prime. I don't want 14. So I'm going to put 7 and 1 there. I want to get positive 7x minus 2x, like that. Okay. Now I see a factor of x minus 1 divided by x minus 1. That leaves me with factors of positive 1. I believe in class we ended up with the same thing. We just had a factor of -1 out front or up top. The opposite of x plus 1 divided by 2x plus 7. Just be very careful with this, with how you write this. Do you notice how far off to the left I'm putting my negative? Do you notice how I'm trying to keep it lined up with my fraction bar? If you write negative x plus 1 divided by x plus 7, I don't know if that's right or wrong. I don't know if you know what you're doing or not. So that's going to cause a loss of marks. If you want to make it absolutely clear, this first solution could just have brackets around there. There's nothing wrong with that. If we had brackets here, now there's nothing wrong with that either. So you're not marked on your handwriting in this course, but your reader needs to be able to read your work. Sloppy placement of negative signs, not caring about where we put it, can cause problems. Restrictions, x minus 1 can't equal 0, so x can't equal 1, and 2x plus 7 can't equal 0, so x can't equal -7 halves would be our two restrictions there. Okay. I just wanted to present it as an option. I really do think you want to get used to factoring in this order. It should have been useful in some grade 10 quadratic word problems, and you'll see it in advanced functions problems as well. I think it's another one of those cases where it might take a little bit of effort to learn how to factor it in a different order instead of just staying with the way that you have always done things. But not wanting to use a new method just because it's new is not a good reason to avoid learning something new. So try it out.